Crews on board the International Space Station work on science experiments, as the crew is doing today. Also, maintenance and upkeep of the station and its hardware. They also work on a lot of educational competitions or challenges. Uh, there's one of those that's underway now that combines thinking out of the box with a new 3D printer that's on the station. My colleague, NASA commentator Lori Meggs, is at the Payload Operations Integration Center at the Marshall Space Flight Center in Huntsville, Alabama, with some special guests to talk about 3D printing for future exploration.
It is an exciting day here because we have the Future Engineers Tool Challenge winner, R.J. Hillen. He designed a tool that could be created to use in space for future exploration, and he's here with us today because, as you said, an exciting day. He gets to speak to Tim Kopra and Jeff Williams on the International Space Station in just a couple of hours, and kind of chatted up about his design, and then they just recently printed that, so you can find out what they think about it. What's this day mean to you, RJ?
It's a really exciting day. It's an opportunity for me to do what I've always wanted to do, which is to get involved with space exploration and really create new and exciting things that can be used off Earth.
What's the number one question you want to ask them?
Probably what they think the future of 3D printing will bring for space exploration.
What do you think that is?
I think it's going to be the ability to basically create on demand and maybe make things that many people don't really think that will be necessary in space.
So let's back up a little bit, just a bit. You were a senior in high school, and how did you learn about the Future Engineers Space Tools Challenge, and why did you want to participate?
Well, I actually learned about the competition through an ad that I found on the internet. I just was browsing through, I think it was like nasa.gov, because I saw some new article, and then I found the ad. I clicked on it, and I read through it. After realizing that it was an actual competition, I wanted to participate. I mean, I've always been interested in space exploration, so it gave me an opportunity to really kind of like put forth my knowledge and test myself out.
So a senior, Enterprise High School. What'd your friends think or what did you think, I guess, first of all, when you learned that you had won?
I was really excited. I mean, I knew that meant that, my design got to be put up into space, so it was really exciting, kind of just solidified that I knew what I was talking about.
Just a couple of tweets and a couple of Facebook posts, right?
Yeah, just a few.
So tell me now, tell us what the tool is. I guess you should talk a little bit more about that.
So the tool is called the Multipurpose Precision Maintenance Tool, or MPMT, and it's basically like a small little block that has a variety of different tools that astronauts could use on board station.
All right, and I think this challenge has really, from what I understand, kind of changed your life.
Yes, it's changed my actual career path drastically. I've managed to meet so many people, CEOs, Dr. Barnhart from the Rocket Center. I got to meet the director of Marshall, a variety of astronauts. So it's really changed my career path from really focusing on being a sole engineer to trying to look at different opportunity in the business side of things.
So future engineer and businessman, I
Yes.
like that. Well, and then we're so glad you could be with us today and you get to talk to the crew. I've never gotten to talk to the crew. That's cool, RJ. Let's bring in Nikki Werkheiser now. She is the In-Space Manufacturing Project Manager for NASA here at Marshall. And Nikki, what do challenges like this really mean to NASA?
They mean a great deal. As a matter of fact, our in-space manufacturing project is actually under NASA's Advanced Exploration Systems. And so the whole goal of our projects really is to develop the technologies that we're going to need to travel to destinations such as Mars. And these are quite different missions than what we experience today on Space Station. You're talking about sometimes up to a 3-year mission, so it's quite a paradigm shift. The exciting part about in-space manufacturing is that we can really adapt and leverage the rapid evolvement of evolution of additive manufacturing technologies commercially on the ground and really adapt them for our in-space needs, the form, fit, and function that we need. However, as important as the technologies are, the skill sets that we need to design and build these parts is of utmost importance. So from the inception of the project, we really knew and understood that we needed to help develop these skill sets, and what a more exciting area than in-space manufacturing to do that with. So we started through the American Society of Mechanical Engineers, this new STEM program through a Space Act agreement with NASA, through our Advanced Exploration Systems Office, to really excite students today to design parts that we can use in space. I'm very thrilled to say we're actually on our 4th challenge, and RJ was our first teen winner, and we have all kinds of exciting prizes. But really to spark the creativity that's already there in our students and show that there's a viable career path in this area. What I really love is that in STEM, a lot of times we target your math and science students that already kind of have a affinity for those subjects, but this is a creative process. So many times I'll be working with students and we'll be designing a part, and I'll say, you know what you just did? You just did engineering. And the light bulb will go off, and they'll say, no, I couldn't do that. I'm not really good at math or science. And we say, you did. Engineering is a state of mind. It's not a degree on a wall. And that's what we want to develop in this whole industry that's going to help NASA get to Mars. I'm really too old to go to Mars, unfortunately. But
No.
Yeah, well, and this is the generation that will get there. So we really want to make them feel part of the process today.
So tell us where we are with additive manufacturing, the AMF, and 3D printing, same thing, really. You've got 2 printers now on station. Tell where we are and where we're going.
Well, it's going to be a very exciting few years. We actually, under the In-Space Manufacturing Project, have a phased technology development roadmap of all those technologies that we're going to leverage. Space Station is an absolutely critical test bed. It is the only laboratory, crewed laboratory we have in microgravity to test all of this out and to get ready for those exploration missions. So now, as you mentioned, we have 2 printers. We have the 3D Print Tech Demo that flew September 2014 that we're getting ready to start our phase 2 of operations. And we have the Made in Space Additive Manufacturing Facility. The really exciting thing about AMF is this is actually a commercial printer that is owned and operated by Made in Space, Inc., out of Silicon Valley, California. And through the ISS National Lab and CASIS, not only NASA will be using this printer, but other entities in industry, academia, other government agencies can all print on Space Station to manufacture parts. So not only will you see the first ever student design part manufactured on station, you'll see all sorts of exciting things. On our roadmap next year, we'll actually be launching the first ever in-space recycler with a company called, yes, it's really going to be the step that takes us to more of a closed loop, sustainable system, more autonomy and sustainability during these missions that our astronauts are going to need, that we can recycle the 3D printed part back into filament and then make any new object we want. And we're doing printable electronics. We're doing more autonomy.
I think you mentioned clothing, too, maybe in the future?
Yes, so there is a AES project as well that works on, when you think about a 3-year mission, my closet looks pretty rough right now, so I can imagine a 3-year mission, we have to bring enough clothes for everyone. So one of the options could be to actually 3D print those clothes.
Do you hear that, RJ? You need to get on that clothing thing now. So, again, if you want to get involved, if you're a student out there watching, you go to futureengineers.org. They have challenges going on all the time, and we hope to see you here. Maybe you can be like RJ someday and talk to the crew, and that happens today live on NASA TV at 12:30 Central Time. And I might have a few questions that you can ask him, RJ. No, he's got his own. That'll do it for us here from the Payload Operations Integration Center. Now back to you at Mission Control in Houston.